So we've been talking about Ohm's law, and this question asks you to use Ohm's law, but it asks you what happens if you've got, in this case it's an extension cord. You've got a nice extension cord. Mine's orange because I have a nice orange extension cord at my house. It's got a really low effective resistance, got the same amount of current running through it. What happens if you have a much higher, in this case 5 times higher resistance in the cord because it's cheaper, and you run the same current through it? What is the difference in potential drop in the cord itself? And if you're using the same cord to run an appliance, then what happens to the appliance? What is the effect on the appliance? So in this case, we've got 2 different resistances, but the same current. So we find 2 different voltage drops. So just use Ohm's law, and I times R in the first case, in the nicer cord, is 0.3 volts. So the voltage that is basically dissipated, is used up in the first cord, is 0.3 volts. The second cord is cheaper. It's not as good. You've got 5 amps, but it's dropped across the resistance of 0.3 ohms. Then you lose 1.5 volts. So that amount is actually just used up. And the problem asks, what's the effect on the appliance? But there's also an effect in the cord. If you have a higher resistance, you have what's called joule heating. You have actually power loss in the cord, and it'll heat up, and that can be dangerous. But the effect on the appliance is that there's less voltage available to use, so the appliance will actually get less power, and it may not even work properly if you use a cheaper cord. And so one really cool thing about talking about circuits is that most of us see this every day. We see circuits, we plug things in. And so you have actually some really cool applications of Ohm's law in your everyday life, and this is actually one of them. So think about that the next time you flip a light switch on.